just a vacation day. I don't know.
It's a national holiday.
What holiday?
We can make one.
Can I just complain for a little bit here?
No, let's get started.
We have not used our snow days that we were allotted.
We've used
We
one.
still have one left.
We have
Yeah.
two.
No, because we had 2 early releases.
Yeah, but those don't count.
Oh,
It's still February.
Pile them on. No, because now if we get snow, it won't stick around.
There have been snow days in March and April before.
Like, honestly, it doesn't affect when we graduate, so why couldn't we have like 10 snow days this year?
Yeah. We're getting out early anyway.
Yeah? Okay. You don't,
Jake, you don't have school next Friday.
and I don't
Be
have school
happy.
Thursday, so I guess it's like.
Stop complaining.
Oh, 4-day weekend, Q?
Yeah.
All right.
Give me some of that.
The distance problem. So, ladies, gentlemen, need your attention up here, please. This is the reverse of the velocity problem in a way. So, the idea here is finding the distance traveled by an object during a certain time period if the velocity of the object is known at all times. So it says if you know that the velocity is constant, the distance problem is easy to solve by using the distance formula. Distance is rate times time. The rate is the velocity. But if the velocity varies, it's not as easy to find the distance traveled, but it's also not impossible. So here is an example of how to work through this. You're not just given an equation for the velocity function, you're given the velocity at certain times. So it says, suppose the odometer on our car is broken. We want to estimate the distance driven over a 30-second interval. We take speedometer readings every 5 seconds and record them in the following table. So here are the velocities in feet per second every 5 seconds from 0 to 30 seconds. So we're going to work through this 2 different ways. The first way says to approximate, we're just going to work through approximating the distance traveled in each 5-second interval. So actually what I'm going to write out here, this is just easier for me to see. So if we have the interval from 0 to 5 seconds, 5 to 10 seconds, 10 to 15, 15 to 20, 20 to 25, and 25 to 30. So we have 6 5-second time intervals. And what we're going to do is calculate the distance traveled or approximate the distance traveled over each of those 6 5-second intervals. And there's 2 ways to do that. So the first way, and I kind of have this explained in detail here, if we approximate the distance traveled during the first 5 seconds, the first way we're going to do it is assume the velocity is constant throughout the interval, taking the velocity during that interval to be the initial velocity. So we are going to assume from 0 to 5 seconds, this is a short interval, that the velocity in that interval is constant and it's 25. So then by assuming that, we can use this equation above to say then the distance in that time interval is approximately the velocity, which would be 25, times the 5-second interval. So the distance in that first 5 seconds would be approximately 25 times 5, 125 feet. Okay, and then we would do the same thing now in the second time interval from 5 to 10 seconds. Assume again the velocity is constant in those 5 seconds, and we're going to take the velocity during that time interval to be the velocity when the time is 5, so the initial velocity of the interval. So now we're assuming from 5 to 10 seconds the velocity remains 31 feet per second. So then the distance, approximate distance in that interval would be the 31 feet per second times the 5 seconds. And that would be 155 feet. Okay, and then we would do that for every interval. So you're using, for each of those 5-second intervals, the initial velocity of that 5-second interval. So this is what it would look like if we kind of wrote out all 6 intervals. The total distance would be approximately. I'm going to also rewrite these two, not the final amounts in feet, but how we calculated them. So we're taking from the first 5 seconds, the velocity of 25 times the 5 seconds, plus for the second time interval, 5 to 10, the initial velocity when t is 5, so 31 times 5. So then the third time interval that we didn't write out yet, from 10 to 15, we're taking the velocity when the time is 10, the initial velocity of the interval, so 35 times 5, plus the fourth interval, 15 to 20 seconds, taking the velocity when time is 15, so 43 times 5. From 20 to 25, that interval, taking the velocity when time is 20 seconds, so 47 times 5. And the last 5-second time interval, taking the initial velocity in that interval, which is 46 times 5. So we would multiply each of those, add them together. It should come out to be 1,135 feet. Yes. Just now. Thanks. Okay, so that was calculating or approximating distance, assuming that for every time interval, the velocity was constant at what it started at. We could also, well, first of all, are there questions on how we got that number? Okay, so we could also have used the velocity at the end of each time period instead of the velocity at the beginning as our assumed velocity. So we could have used, for those first 5 seconds, rather than using the velocity when t was 0, we could have used the velocity when t was 5 for the first 5 seconds. So we could have said in those first 5 seconds, the distance was 31 times 5. So we could have said the distance covered during the first 5 seconds could have been 155 feet instead of 125. Okay, and then the second time interval, 5 to 10, we could have used the 35 feet per second as our assumed velocity instead of the 31. So the second time interval, the distance could have been 35 times 5. So 175 feet instead of 155 feet. Okay, we could have continued that for all of them. So then this is what it would have looked like all written out. So the first time interval would have been the 31 times 5. Second interval would have been the 35 times 5. Third time interval from 10 to 15 seconds. We could have used the velocity at 15 seconds at the end of the interval. So you had that be 43 times 5. For the fourth time interval, 15 to 20, use the velocity at 20 seconds. So 47 times 5. For the fifth time interval, use the velocity at 25 seconds instead of 20, so 46 times 5. And the last time interval, use the velocity at 30 seconds rather than 25, so 41 times 5. And so again, this would then just be a calculation, multiply, add those 6 distances together, and you'd get 1,215 feet. Okay, so what we got from this, we got a lower estimate for the total distance and an upper estimate for the total distance. Now, this might...
That's an underestimate.
This might from Monday. This might from Monday remind you of the of 2 of the 3 approximations we found with right and left endpoints. This first one, if we use the velocities as the initial velocities in each time interval, that is the same as calculating with the left endpoints. And then the second one we found, if we use the ending velocity in each time interval, that's using the right endpoint of the interval. So that's how this is tying into what we found on Monday. We're just now aligning it to, if you have velocity, by finding this, you're finding the total distance. Okay, so I have an even, maybe a more clear way to relate this to what we did on Monday. If you look at the back, one question I have, so you saw the 2 estimates we had. We had a lower estimate and an upper estimate. How would you get a more accurate estimate? I'm hearing a lot of things. Can somebody just say smaller rectangles? So we had 5-second time intervals, and therefore we only had 6 intervals. Increase your number of intervals. Take smaller chunks of time. So maybe shorten the time intervals. Do 1-second time intervals, and then now you have 30 time intervals versus just 6. That's going to give you a more accurate lower and upper estimate. But then what I have below that is just kind of getting you that idea of a limit once again. This is actually a graph of the velocity that we had in the table on the front page. So I have those velocities all plotted there. We could connect them, since velocity would be continuous, kind of connect them with a smooth curve. We don't have an equation for it, but I want to tie this into what we did on Monday. I already have the x-axis in intervals of 5. So if you were to tie in what we did on Monday and say, I'm going to take the interval from 0 to 30 and divide it into 6 intervals. I need to teach this, so can we talk about that later? Okay. So divided into 6 intervals, and then on Monday we looked at estimating or creating rectangles from these by using the right endpoints or the left endpoints. So realize if you took right endpoints, I'm just going to kind of sketch what these rectangles would look like. Some of the rectangles would be above the curve, some would actually fall below. But if then you were to find the area, we'll just look at the first one. The area of that first rectangle, they all have a width of 5 seconds, so they all have a width of 5. The height of that first rectangle is the function value when t is 5. So from the previous page, that height was 31. So with right endpoints, this area would be, the height is 31 times the width is 5. And that's what we saw. I'm going to be flipping back and forth here. That's what we saw here. That first time interval, that first distance traveled was 31 times 5. And we attributed that to right endpoints. So by finding the area under this curve using right endpoints, you're going to get the second estimation we came up with on the front. If you use left endpoints, I'm just going to use a different color to draw those heights over. Okay, but left endpoints, then that first rectangle would have had a height when t was 0, which was 25, width still of 5. And so that first rectangle would have had an area of 25 times 5, which, again, I'll flip back to this. But the first estimate we found, that was the first distance traveled, was 25 times 5. So what this is relating, just like I said, tangent problem, velocity problem were the same process. The slope of a tangent line is the same as the instantaneous velocity of an object. This is saying that if your curve represents velocity, the area under a curve is the distance traveled by that object. So finding the area under a curve and then approximating distance traveled are the same process. Area under a velocity curve is distance, is what this is saying. So what's explained below? It says, in general, suppose an object moves with velocity v equals f of t, where t is from A to B. F of t is greater than or equal to 0. So that's saying the object always moves in the positive direction. Total distance traveled during the time interval A to B is approximately. So this is written out. This would be with left endpoints that we found first. This is just the sigma notation. Right endpoints. And then the exact distance would be the limit as your n approaches infinity. So as you get more and more time intervals, you shorten those time intervals. The limit of the left or right endpoints would be equal. That would be your exact distance traveled. And as I already talked about, distance traveled by an object is equal to the area under the graph of the velocity function. So just tying those two ideas together. So I just have, we're going to do one more thing today, but for just practice with these, in addition to what we did Monday, 11 and 13 focus on being given velocity, finding distance. Okay, so are there questions on that? We'll find the exact without calculating the limit. Yes. Yes. Okay, then the second part, I'm going to pass out one other thing. These calculations, rather what we did Monday, you are able to find right and left approximations for area under a curve on your graphing calculator. I did.
That's the demand curve. Income demand curve right there. You right.
Galen was at the winter festival. He was bowling.
Okay. Guys, on your graphing calculators, I have talked about how what we did on Monday, especially it ties in more with Monday, when you actually had the equation of a curve and you were asked to find an approximation using right endpoints or left endpoints for a certain number of rectangles. The process is more tedious than anything. So especially if I said find this for 20 rectangles, that would take a while to find all of those areas and add them together. Your calculator can do this. So do you need to know how to do it by hand without a calculator? Yes. Should you know how to do it on your calculator? Yes. So you need to know both. This is what the command looks like. And if you have an 84, which I know a lot of you do, the calculator will put this together for you. There are still some steps you need to take on your own. You need to know what to enter in. But in this whole expression, so you're going to be typing in the sum and the sequence. F of x is your function, it's your curve. Delta x we've learned how to find. X is just defining that x is your variable, so you would actually put x in there. X sub 1, it says below, is the x value at which the height of the first rectangle occurs. It is not necessarily the a value of the interval. It's the height at which the first, or the x value at which the height of the first rectangle would occur. X sub n is the x value at which the height of the last rectangle occurs, and then again delta x, you see there again. So this is how you use your calculator to do this. So this says compute the sum of the areas of approximating rectangles using equal subintervals and right endpoints for the given n value using your graphing calculator. So we have the region under f of x is 25 minus x squared from 0 to 5, and our n is 5. So we have 5 rectangles. So I would start out like you were going to do this by hand. I would first find what delta x is. How do you calculate what delta x is?
It's 1.
So it's your b minus a divided by n. A in this case is 0, b is 5. So it'd be 5 minus 0 divided by 5. So your delta x is 1. And then I would write out your intervals. So first interval would be 0 to 1, then 1 to 2, 2 to 3, 3 to 4, 4 to 5. Okay, now you're going to let the calculator do the rest of the work for you. You just have to know what to type in where. So what you have to do is you have to enter in the sum and the sequence part. You have to tell your calculator to do those two functions. So where to find those? To enter this command in your calculator, to find sum, you go to second stat, which is list, and then you arrow right to math, and it's option 5 is sum. So second stat, go over to math, option 5 is sum. Then you do that again, second stat, but now only arrow over to ops and do option 5 there, which is sequence. Now, if you have an 84, this may have come up on your screen. If it did not, if you have an 83, it would not have. Just hold tight. AB. Yeah, no problem.
You see, it's called 2. Saturday.
I don't know.
Go down.
I don't know. All right, so if you did not get this screen, just hold tight. If you got this screen, guys, maybe focus on your calculus and just leave them alone, please. So, expression, EXPR. What you need to type in here, this is only if you got this screen. What you need to type in here is your function f of x multiplied by your delta x value. So for us, it would be the quantity 25 minus x squared times our delta x is 1, which you don't really need, but in some cases you will need to actually put a value there because it will not be 1 every time. Okay, so your f of x times delta x goes in the expression. So that it's representing the height of your rectangle at any x value times the width would always be your delta x. So that's what this is standing for. Your variable is always just x, because it's whatever variable you entered into your first expression. Your start from what I described above would be whatever the x sub 1 is, and the x sub 1, again, if you read above, is the x value at which the height of your first rectangle would occur. So if you look at your intervals and we're using right endpoints, what is our x sub 1? 1. For right endpoints, the 1 would be x sub 1. Okay, the end is your x sub n. And if you read above, that's the height, or that's the x value at which the height of your last rectangle occurs, which for us would be what? 5. Okay, if we had left endpoints, our x1 and xn would be different. Your step is your delta x. So we would put 1 there. And then the paste is just when you enter it all in, you click paste, and then you go. So I'm going to type this in, and I know, again, not all of you have this screen. If you don't, just wait. So expression, I have to type in 25 minus x squared, because it's just multiplied by 1. Variable is x, start is 1, end is 5, step is 1. Click paste. Now, look what comes up on your screen. This is the format of what I just had written up here. Your calculator just types it in for you. If you did not get this screen, you have to manually type this in yourself. So I'm going to stop here. So when you have, if you have an 83, once you type in the sum sequence, you actually have to type this string after. So you would type in the 25 minus x squared. Again, it's multiplied by 1, but you don't really need that there. With a comma, then type in x with a comma. Your x1 is 1, comma, your x sub n is 5, comma, your delta x is 1. So you would actually just have to type that in yourself. Once it's typed in, though, you hit enter, and it calculates it. You should get 70. Okay, so I'm actually going to write this out just so if you want to write it down, you know what you saw in your calculator. This is the command your calculator showed you. Sum sequence 25 minus x squared, comma, x, comma, 1, comma, 5, comma, 1. And then there'd be a couple of parentheses really to close all of that. But then it equals 70. So rather than finding all 5 of those areas and then adding them all together, your calculator will do that. And it's very helpful, especially when you get more rectangles, such as 20 or 50. You don't want to do all of that by hand. Okay?
I got it.
So the next one, I'll put this back up here, but the next one I'd like you to do on your own. See if you get the right answer. But if you did not get 70 or had trouble typing this in, then you can let me know while I'm walking around. Do the second one first, get the value from the right, find both. Find the value from the right and the value from the left. Find both the left and the right approximation. So for number 1, the 70 is just the right endpoint. This would be R sub 5, right endpoints with 5 rectangles. So find for number 2, find R sub 10 and L sub 10. Find both. Did you guys all get that?
Yeah. Oh, my boy, I messed up on that one.
Sure you got that answer yet?
Oh, we're going through the live. Yeah, but it's from 1 to 2. Yeah, yeah. So I think it's
Well, you have to do from the left.
no, from the right would be 1 2 from the left. Yeah. Whoa.
I thought it was last week. And I purposely didn't show up. So this time it was
I think it's one.
no, I don't want to go.
I really don't want to go
From 1 to 2.
You never get anything right. I don't do No, no one showed up. He was there. I was very disappointed. You never got smarter off and they scheduled the same time tomorrow. Alright, please arrive at time to get the song. That's a lie. I got it. And they did everything. Yeah, why not? Oh, multiply it. Oh, shit. Oh, I didn't do that. Oh, no, you can't.
Yeah, I did that. I did that. Oh, did they get this?
I got 0.5 left. The other one? Yeah.
Then you just grab it.
I don't know.
Okay, here's what I'm going to do. I'm going to write down what the right and left approximation should be in your calculator, and then if you did not get that, I can look at why you didn't get it. So the right approximation should have been approximately 0.464. The left should have been approximately 0.539.
Why do you have to, what's with the endpoints where it's just 1.1 and 2 and it's 1 and 1.9? Why is that?
No, I don't know what you mean.
I don't, I got the answer, I just don't understand why. Can you just come over and see if I'm doing this right?
Yes, just 1 second. So if you didn't get these, here's some things to check. For this problem, what is your delta x? 1/10 or 0.1. So if you listed your intervals, really you just need the first interval and the last so that you're able to see from the left or right what your beginning height and your ending height would be. The first interval, you're starting at 1, would be 1 to 1.1. Your last interval would be then, if you're ending at 2, go back 0.1, you're at 1.9. So for the right endpoints, 1.1 is your x sub 1 and 2 is your x sub n. For left endpoints, 1 is your x sub 1, 1.9 is your x sub n. Okay, and then also make sure for your expression that you multiplied f of x by delta x. So if you aren't able to get these and don't know why, let me know.